everyone, my name is Ryan Ghazi and I'm the Teacher Development Manager for Macmillan Education International Curriculum and Caribbean. Thank you so much for joining our webinar this evening in the UK with Tony Cotton, who's going to be focusing on mathematics teaching and stories. If you have any questions, as always, please feel free to write them in the chat box and we will do our best to answer your questions. I will pass it over to Tony now. Thank you.
Hello everybody. I'll turn that light down slightly in the background. As you can see, it's the evening in the UK, and I'm sitting in a little shed outside my house in a place called Otley, which is just north of Leeds in the north of England. I was interested that there are at least 3 people from Manchester in Jamaica have joined us. I don't think there's a Leeds in Jamaica. I was fascinated when I visited Jamaica a couple of years ago. I came 2 or 3 times in a year, and there are lots of place names that we share from our shared history. But I don't think there is a Leeds. Neither is there a Yorkshire, which is where Leeds is. But it's wonderful to have so many of you here and joining the webinar. This is the second one today. We had a great time earlier on. About 4 hours ago, we ran this webinar the first time through, and people seem to enjoy it. So I hope you enjoy it as much as the participants did early this afternoon, and I hope I enjoy it as much as I did early this afternoon as well. I'm sure I will. I've really enjoyed thinking about mathematics teaching and stories. When Macmillan asked me to plan this webinar, I've very much enjoyed thinking about it. And one of the things I've enjoyed is trying out all of the activities that I'll introduce to you with my grandchildren, just to make sure they were fit for purpose. As well as being a mathematician and a mathematics teacher, I read all of the time. I'm an avid reader, and it's been a treat to put those things together. I'm a member of a book group that we read books together. I'm sure many of you are in similar groups, and we read themes. We tend to read 7 or 8 novels, mainly novels, around a theme each time. 3 themes ago, the theme was around mathematics, and that was how mathematics is involved in some novels. And currently, where our theme is Afrofuturism. I don't know if you've heard of Afrofuturism as a genre. It's science fiction, but written by writers from Africa and African-American writers. In fact, Beyonce is seen as somebody who's an Afrofuturist because of particularly her last album, which was very much kind of quite science fiction-y. And of course, there's lots of mathematics in science fiction novels. But we're not talking about science fiction today, and we're not talking about maths in novels. We're talking about creativity and how we can use stories to teach mathematics. I know that several of you attended the previous webinar. We looked at mathematics in the real world. There's a real storm breaking here. You may start to be able to hear rain. It's very windy and very wet. So if you can hear a storm in the background, that's actually a storm in England. Not as bad as storms that you get, but fairly bad for storms here. But I'm sure I'll survive, and I'm only about 10 yards from my house if it gets too damp. Anyway, for those of you that were in the last webinar, you'll remember that I used those same phrases to introduce myself. I said I'm a mathematics teacher and a teacher of teachers of mathematics, and I do both of those things. So I still teach mathematics. I teach mathematics to children in schools whenever I can. Obviously, that's been limited in the last year. I teach mathematics to my 2 grandsons. During lockdown, that's been the highlight of my day, has been my Zoom lessons with my grandsons aged 8 and 3, and I'll talk a bit more about them later on. And I'm also involved at the moment in teaching mathematics online to children in refugee camps in Greece. I think one of the fascinating things about the last year and about learning to teach online and learning to teach remotely is how quickly we've adapted to new ways of working, and to some extent taken advantage of new ways of working. So it allows me to talk to currently 133 teachers in the Caribbean without leaving my shed in Otley. Obviously, I would much rather be with you in person in the Caribbean, but actually I couldn't be with all 133 of you. So it's a way of actually interacting with many more people than we used to be able to. I also use the phrase that I believe our understanding of mathematics impacts on our understanding of the world. And I think that is why I teach mathematics. I teach teachers of mathematics because I want children to learn mathematics well. And I enjoy working with teachers in exploring how together we can teach mathematics well in order to develop mathematicians in our students. You might remember that last time I used an example of modeling the COVID virus as a way of using mathematics to help us understand the world. Let me use a different example this time. I want you to try and estimate how long it would take you to count to 12 million. If you started at 1 and started counting 1, 2, 3, 4, 5, 6, and so on, how long would it take you to count to 18 million out loud? So start thinking about how you might do that, and if you can start to calculate that and put some of your thoughts in the chat box, that would be really, really helpful. Again, as you know, the people that joined us last time, we will do mathematics during this webinar. I will ask you to engage in some activity. So this is your first activity. How long would it take you to count to 12 million? Also give me a break to have a sip of my coffee. And we'll see if your answers agree with the answers from the people this afternoon. Hi, Romain from Jamaica. Okay, 16 million seconds. Can you work out how many hours and minutes or even months and weeks 16 million seconds is? Hoshi and Tracy Ann, how long would 6 million seconds? Michelle, how long is 12 million seconds in? Is it a week? Is it more than a week? Is it a month? And Tracy Ann, thinking of counting 2 numbers a second. When I get to more than a million, I would be counting, well, let's say 3,425,101, 3,425,102. So suddenly it takes me longer. I can say two numbers a second for the smaller numbers, but so it's going to take us longer than 12 million seconds. What do you reckon, Michelle? How long is 12 million seconds in months and weeks? Maybe 12 million is more accurate than 6 million, because that takes into account. Okay, about a month. That's Michelle. With that would be, I guess, without taking a break. So if you think about taking breaks, if we were actually doing that, we suddenly start to double the amount of time. Okay, Hoshi reckons about 185 days. So that's just over 6 months. Tracy Ann thinks 5 weeks. Any other thoughts? I'll wait until this next person's thought comes up. 2 months from JD. I do apologise if I mispronounce your names. The disadvantage of not being live is you can't correct me. Okay, 5 weeks round the clock. I'm not going to give an answer. There are a whole range of answers. I think the answer around 6 months is probably more realistic in terms of what people have said this afternoon. When I've done this task quite often with groups of people, sometimes they time themselves reading out numbers and take an average. Sometimes they make an estimate in terms of number of seconds, and then obviously divide by 60 to find out how many minutes that is, divide by 60 to find out how many hours, 24 for how many days, 7 for how many weeks, and so on. And I think we're probably talking somewhere between 6 and 9 months as an accurate estimate. And then we can agree whether that means that we're stopping for breaks and how long the breaks are. And one of the interesting things, I think, is actually having a conversation with students and having a conversation with learners about the fact that there can be different answers, and the different answers depend on the constraints that we've put on the calculation and on the problem. Now, there's a reason that I chose 12 million, and that reason links back to our understanding of mathematics impacts on our understanding of the world. 12 million is one estimate for the number of African people displaced from Africa during the 400 years of slavery. Now, if we say, and suddenly that 12 million takes on a different sense, doesn't it, a different aspect. When I do this activity live with people, you get a different feeling in the room. There's suddenly a sense of the importance of that number. And I think that's an illustration of how suddenly the mathematics has allowed us to think about the world in a different way. We understand the evil of slavery at a human level, but we probably can't contemplate the impact that had on people without trying to think about big numbers. And 12 million is very difficult to get our heads around in terms of a large number. But if we think it would take us over 6 months to count all of those people without sleeping, suddenly that number makes some kind of sense, and we can work out how enormous it is. I've carried out that activity in Europe, and we use 6 million as the number. 6 million is the number of people killed in the Holocaust in the Second World War. And again, you can feel the atmosphere in the room change when we kind of understand that number. So that's what I mean about using mathematics to understand the world. We can make sense of the world in a different way if we understand the mathematics. Now, often we understand the world through stories. We tell stories about the world, and we tell stories about ourselves in the world. And I think that's also another way of using mathematics to develop our understanding of the world. The last webinar was about mathematics in the real world. And I used this slide. I used my definition of what mathematics is. And I told you it was created from the New Zealand curriculum, the UK curriculum, the Jamaican curriculum, the Belize curriculum, the International Baccalaureate curriculum. Kind of pull them all together to get an overview of what mathematics might be. And this is my particular definition. And this is the definition that I try and work with in my work. So I think we use mathematics in two ways. We use it to explore the worlds we live in, and we use it to explain the worlds we live in. And without mathematics, we can't explore the worlds we live in as effectively, and we can't explain the worlds we live in as well. deliberately using the plural for worlds. So the worlds, we have social worlds that we operate in, and that can include our work and includes our teaching. We have political worlds that we live in. What we teach is decided by our governments. The way that we teach is sometimes decided by our governments. So the political world impacts on our social world and on our teaching world. And we have a creative worlds that we live in. And those worlds overlap. And we explore those worlds using mathematics, and we can explain the worlds using mathematics. And today we are looking at the creative world. And the reason that I think that's useful is that it means we can move away from just seeing mathematics as functional, just seeing mathematics as something that we use in other subjects or that is useful in our everyday lives. Of course, that's an important part of mathematics, but mathematics is more than that. Mathematics can be creative, and mathematics can be interesting just of itself. And I don't think we should worry too much about that, because sometimes when our learners, when our students ask us, what's the point of us doing this? I'm never going to use it in real life. We might say, no, you're not, but it's interesting, or it's fascinating, or it's creative. When we're working on storytelling and when we're working on writing, we're not always saying you will need this for later in your life. We're saying this is interesting of itself. So today we're looking partly at mathematics as a creative activity. So let's start with a story problem. One of the interesting things about mathematics and stories is that in the very early days of mathematics, in the very early days of science, often problems were set as stories. The way that mathematicians would engage each other is by telling a story. And this is an example of one of those stories. And I first came across this 4 or 5 years ago when I was doing quite a lot of work in the Middle East, and I was working in Oman, which is just on the Gulf. And it's a story from 1256, so it's an 850-year-old story by Ibn Khaldun, who was an Islamic scholar in what is now Iraq. And I'll just read through this and then we'll think about it. A wise old ruler wanted to reward his servant for an act of extraordinary bravery. The servant said, "Master, I ask you for just one thing. Take your chessboard, same as a checkerboard, and place on the first square 1 grain of rice. On the first day, I will take this grain home to feed my family." So it wasn't going to be much of a meal on the first day. On the second day, place on the second square 2 grains of rice for me to take home. Still not much of a meal. On the third day, cover the third square with 4 grains of rice. So you can see what's happening. Each day, he's getting double the number of grains of rice. And that's what he says. Each day, double the number of grains you give me until you've placed rice on every square of the chessboard. Then my reward will be complete. The wise old ruler replied, "This sounds like a small price to pay for your act of incredible bravery. I will ask my servants to do as you ask immediately." So let's think about whether or not it's a small price to pay. So what we're doing is we're doubling the number of grains of rice on each consecutive day. So on day 1, you can see there's 1 grain of rice on that square. On day 2, there are 2 grains of rice. On day 3, there are 4 grains of rice. Can you carry on with that doubling and try and calculate how many grains of rice there would be on the 64th square? Now, I'll tell you now, it's a lot of rice, but I'd be interested in you starting to work towards it. And again, we'll see how we do compared to this afternoon's webinar. I'll give you a piece of information. In a £1 bag of rice, there are 25,000 grains. So one thing you could do, and you will need a calculator, use your phones or use a calculator, is work out on what day would he be taking a bag of rice home, or more than a bag of rice? On which day would the brave man be taking home more than 25,000 grains? So start doubling and see how it goes. Hi, Alicia and Charlene in Jamaica. We had a lot of people from Jamaica this afternoon, and we're nearly up to 200 people, which is fantastic. So we got 200 people doubling, and let's see where we get to. See how many times you have to double to get to 25,000 is your first task. So 2,048,000. Which square is that? That's not quite the 64th square. I wonder which square that was. Thanks, Douglas. Okay, so to explain to people, 2 to the power 63 means 2 multiplied by itself 63 times. Now, as with the 12 million, that doesn't give us a sense of how much rice. 2 to the power 63 is a very, very big number. Can you create a number, Douglas, so that people get a sense of how big that is? Which square do you get 15,625 grains of rice on, Nicole? No, it's more than that. If you double 2 64 times, you're going to get to more than 15,000, honestly. Okay, I'll show you what 2 to the power 63, or 2 multiplied by itself 63 times, looks like. And let you think about that while I tell you another. This is a true story this time, in that when I was a small child, I used to double. Thanks, Douglas. So that's over 9 million. Lot of rice. It is a geometric series because and it's a very early example of a geometric series. A geometric series is when you multiply by the same number each time. So in this case, we're multiplying by 2 each time. And I was saying that as a small child, I remember sitting in the back of my car, the car with my mum and dad, going to my grandma's, and I would double as far as I could possibly get in my head, so I would go 1, 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024, until I couldn't do it anymore, and then I'd write down the answer and see if I could get further next time. So this story problem, this story that was told, on the 64th square, there would be more than 18 million grains of rice, which apparently is 210 billion tons of rice. And when I was exploring the problem, when I was teaching in Oman, the example I used was that it would cover the whole of India with a 1 meter thick layer of ice. There are 64 squares, Tracy Ann. It's an 8 by 8 board. Coming closer to your homes, that would be the same as having enough rice to cover Jamaica to the depth of 3 kilometers. Now that's a lot of rice, but it kind of gives us an image of how much rice there is. We get a sense of it, don't we? We can suddenly get a sense of it. And then what we could do is we could work with that and say, okay, how long would that rice feed the whole of Jamaica for? And we could calculate that. We could say, is that enough rice to feed the whole world? And for how long could it do that? So we can start to to work with those big numbers in different ways. But the story has engaged us in doing some mathematics and making something interesting. So that's there as an example that stories and mathematics have been intertwined for at least 850 years. And actually longer than that. Whenever there's been mathematics, it's been told through stories. And again, I used those images last time because as I was thinking about this webinar, I was remembering the last webinar about real worlds, and I remembered using this slide as an example of real worlds. So the top image of the very small model of my tea, of my sausage and carrots and peas. It's made by Tate, my 3-year-old grandson, and the 3-dimensional shapes made out of the magnetic polydron were made by my 8-year-old grandson. And I used the example there of Reggio Emilia and saying that mathematics was one of the languages that children had to explain their worlds and to explore their worlds and to speak about their worlds. But when I thought about it, both Tate and Felix actually told me stories. They created their own stories about the mathematics that they'd been doing. So Tate was telling me about the cafe that he was working in, preparing the food and who was coming into the cafe. So he'd done the mathematics in order to create the plate of food in the context of telling a story. Felix was telling a story. He told me that the largest of those 3-dimensional shapes was a sports stadium. The next largest of the 3-dimensional shapes was a conference center. The next one was a hotel, and he was telling me stories about what was going on in those places. So it seems to come fairly natural to young learners to tell stories using mathematics. If they have developed their mathematical language, if they see the world in a mathematical way, they will tell stories using mathematics, and they will interpret stories using mathematics. And I think that's kind of what I want to look at, is by mathematizing the world with our children all of the time, they will start to see mathematics in the stories, and then they will start to see mathematics in the world. One of the things that happens to me, I don't know whether it happens to you, is that when I'm planning something, suddenly everything I read or everything I look at seems to relate to the thing that I'm planning. So the minute I started planning this webinar on storytelling and stories and mathematics, everything I read seemed to kind of relate to that. And I was looking at a magazine that I read. It's called the London Review of Books, and they had an article about a new museum in the States, and it's called the Smithsonian National Museum of African American History and Culture. And what we have there is a storytelling stool that was actually made in Ecuador. Now, there's already a fair amount of journeying gone on there, isn't there? So this is Anansi. I'm going to use 2 Anansi stories later on. So Anansi has traveled from Africa, probably via the Caribbean, to Ecuador, and his stories have traveled with him. And here is a storytelling stool with him at the center. Now, I was fascinated by this. I knew I was going to use the Anansi stories as an example of storytelling and mathematics. And I knew that because in my early days as a teacher in the 1980s, I'm quite old now, I worked at a place called the Centre for Multicultural Education, and that was in Leicester in the Midlands of England. And what we were doing was exploring ways that we could draw on the really rich heritage of all of the kids who'd come from all around the world to live in Leicester, and how we could make sure that what we were doing was celebrating all of our heritages and drawing on that. And the Anansi stories were one way of doing that. Now, there's even mathematics in this storytelling stool, which I'm going to ask you to think about. And this is an activity that I did do with Felix and Tate. So that stool is big enough for one person to sit on. So I think you can get a sense of the dimensions of the stool, how long and how wide the stool is. If you get a sense of how big the stool is, you can start to think about how long the web would be. So I think the web has got 5 loops, if you like, in the spiral as it spirals out. So start to think, how long might that web be then? Which is the question I asked Felix and Tate. And then we looked up how long it takes a spider to weave a web. And apparently, the search engine told me that a spider takes about an hour to weave a web, which seems very quick to me. I was amazed. So if a spider took an hour to weave that web, if Anansi took an hour to weave that web, what rate would it be spinning thread? So let's just spend a couple of minutes thinking about that. How long do you estimate that web is that Anansi has weaved? And when you work out how long it might be, at what rate do you think the web was spun? It's always nice to see someone is typing message come up. What's particularly nice about these seminars is that tomorrow I'm actually going to go over to Manchester in the UK, and I'll be with Felix and Tate, and I will tell them that I've been sharing the mathematics that we were doing last week with people in the Caribbean. And what I will do is take all of the different places that you're from, and we'll look at the world map that we've got, and we'll be discovering where you all are. That's how you'd work it out, Tracy Ann. Can you actually work it out? How long do you think the web is, Tracy Ann? And thanks ever so much. You're being one of the really good people about joining in. So thanks for your contributions already. Do you think you can estimate how long that web is? I'm still interested in how long you think the web is, Nicole and Tracy Ann. What do you reckon? Okay, Kana reckons 300 centimeters, 3 meters. Anybody else got any estimates for the length of the web? And this is another example of an activity which doesn't have an exact right answer, but by working on it together, we can get a range of answers and then see which one we think is the most reasonable. Great, thanks. So Pedro thinks 5 meters. JD thinks 1 meter. And of course, these are all possible answers because it depends what we've assumed the dimensions of the stool are. I hope by the end of this webinar, what you will have is lots of activities you can do with the children in your classrooms. That's for you to work out, Tracy, and what the dimension of the stool is. And what we did was that we looked at this picture and then we drew how big the stool would be. We used a model of a stool that we have at home, drew around the top, and then we could draw the web on the stool, and then we could measure it with a piece of string. So we went through the activity that you've just been doing of estimating, and I think that's a really important first step. And then we drew it, and then we opened it out. And then what we actually did was that we split it into chunks. We said, if that long piece of string was an hour, let's split it into chunks of 10 minutes. If we split it into 6, that spider would do that in 10 minutes. And then we can split that into 10, and that's how much the spider would do in 1 minute. So we could do it all by modeling and by manipulatives. And again, it's all started to come from story. Pardon me. Now, as a result of that story, Tate, age 3, went away and started looking for spiders' webs. They went back home again. They'd been staying with us when I worked with them on that activity. And the next day on Zoom, when I was doing their maths lessons on Zoom, Tate said to me, I want to draw you a spiral because spider webs are spiral. And he drew that spiral there for me. And he told me lots of stories about spiders. So again, the stories were going backwards and forwards. And then I showed him that pattern of Cuisenaire rods because we've been doing quite a lot of work with Cuisenaire rods. And you can start to see all sorts of patterns in that spiral. So there's a white rod in the middle. Then there are 3 red rods, which happen to be double the length of the white rod. The green rods are the same length as the red rod and the white rod added together. And you'll see then we've got to get 2 green, 2 purple, 2 yellow, 2 dark green. So there are number patterns being involved. And we were talking about that. And Tate said, that's not a spiral. It's not curly enough. So we started to talk about whether spirals had to be curved. So you can see where there was all sorts of mathematics coming just from thinking about the image of that stool. And you'll find that happens when you use a story as a starting point. It'll go off in all sorts of different directions, and your own mind will go off in different sorts of directions. You'll think of different ways that you can use it. So let's think about Anansi. So this is a version of Anansi on the Yam Hills by Michael Old. I'm not going to read it all because that would take too long. We'll cut through it, and then we'll start to think about the mathematics comes out of it. And this is where I wish I was with you, because really what should be happening is that one of you should be reading this story rather than somebody in an English accent. Anyway, here we go. Anansi and the Yam Hills. Once in a before time, there lived an old woman who had magical powers. Her name was Five. She was also so evil that some people called her a witch. Five hated her name. No one knows why her parents named her Five. When she was a child, other children would make fun of her name. Sometimes when she was within earshot, they would look out the corner of their eyes and giggle as they say, "Give me 5." When she grew up, Five decided to put an end to the name calling, so she created a weird spell. "Anyone who says 5 will drop dead," she said. Then she changed her mind. "No, from this day on, anyone who says 5 will disappear." The spell immediately caused a problem in the country. No one could say the number again without disappearing. Children could no longer recite their 5 times tables. People had to drop the word 5 from their vocabulary. In Five's village, the unlucky number was no longer 13. So Anansi, well, you know the story. Anansi finds out and he starts stealing things from people, because he'll stop them on the street and he'll say, "How many bunches of bananas have you got?" And they'll say, 1, 2, 3, 4, 5. And when they say 5, they disappear, and Anansi gets all the bananas, and so on. "How many coconuts have you got?" 1, 2, 3, 4, 5, and they disappear, and Nancy gets all the coconuts. Anyway, eventually, Anansi meets a clever guinea fowl, meets his match. Guinea fowl said, "You have 1, 2, 3, 4, and the one I'm standing on." What are you doing? That's not the way you count," Anansi shouted angrily. "What do you mean, Anansi?" Mrs. Guinea Fowl said. I don't know of any number called the one I'm standing on." "Start again," Anansi ordered. Mrs. Guinea Fowl began again. "You have 1, 2, 3, 4, and the one I am standing on." "Oh, that's not what you're supposed to say," Anansi shouted even more angrily. "Well, if you're so smart, what am I supposed to say?" Mrs. Guinea Fowl asked. Anansi shouted, "You're supposed to say 1, 2, 3, 4, 5. Oh!" Suddenly, Anansi disappeared because he said 5, leaving Mrs. Guinea Fowl with all the loot that he'd gotten from tricking his victims. And apparently the Jamaican's moral of the story is greedy choke puppy. One of the Jamaican friends this afternoon told me, is it cleave, choke puppy, if I remembered that correctly, which means greedy. So my Jamaican isn't up to scratch, but I'm learning. And I do know that dogs do eat quickly, and actually they can get very poorly from eating quickly. But it's something, the moral is something about that Anansi's greed got him into trouble. And it seems so obvious that the maths is in there. I was fascinated remembering this Anansi story, and excited about what I might do with it, because I remembered that one of the things that I do when I'm counting with children is we quite often sit in a circle, and I'll tell them to miss numbers out in a count and clap instead. So we might all be sitting in a circle, and I'll say that anybody who is an even number doesn't say their number, they just clap. So we go 1, 3, 5, 7. So you start to hear the odd numbers. Now you can imagine sitting in a circle and not being allowed to say 5, because if you say 5, you disappear. So you clap instead of saying 5. And we could switch it. We could say you're not allowed to say 3, or you're not allowed to say 4. We can colour in the patterns on 100 square. So there's all sorts of things that we could do, just taking the not saying 5 as a starting point. It's a great story, isn't it, Michelle? And then that image there is an image of different ways of subitizing 5. You do it with your 3-year-old Kina. They'll love it. That's great. And so if I'm subitizing, and subitizing means when I can just see a number without having to count. So we can just see all of those patterns of 5, can't we, without having to count. If we think about not wanting to say 5, we could say 2, 2, 1 instead of 5, or we could say 3, 2 instead of 5, or we could say 2, 1, 2 instead of 5. And you can imagine the games that you could play with your children to avoid saying 5. And that gets them to start to see all of the different properties of 5. And we can do that with other numbers. So what do people see there? Just quickly put in the chat what you see when you look at that image. You're not allowed to say 11. You're not allowed to say 11, Tracy, and you've just disappeared. 2 H's, fantastic. What do you see in the pattern, Vicky? And there's 5 in each H, although there's 7 in each H, but they share a 3. So there's all sorts of different ways that 3, 3, 3, 1, 1, or a 5 along the middle and 1s along the tops and the bottoms. So there's all sorts of different ways that we can start to make dot patterns. And so one of the things that we could do with the learners is ask them to make dot patterns using the Anansi story as well. Let's just quickly think about another Anansi story and what we could get out of that Anansi story. My other one that I found was the Anansi and the pot of beans story, where Anansi goes to his grandma's house. She puts a load of beans in his hat, asks him to plant all the beans, and then she goes off to market to get the spices, telling Anansi to stir the pot but not to eat any of it, and he's greedy and he eats the beans. And I was reading this story and I was thinking, well, what mathematics can I get out of this story? And straight away I looked at the images and I thought, well, that's interesting because it's a circle. Now, when I used to fly to places, I was always interested that when I flew over rural Africa, suddenly buildings moved from rectangular to circular. If you think about igloos, they're circular. Now, the reason those buildings are circular is because a circle can contain the largest area for any given perimeter. So if we're short of resources, it's best to build a circular floor because we get the most floor space for a given perimeter. Now, that's an activity that we can explore. That's an activity that we can do, thinking about grandma's house. We can calculate beans. How many might be in a hat? How many might be in the pot? How many would fill the classroom? And I'll come back to that in a very brief moment. But we can start to think about volume using the beans. Halfway through the story, Grandma makes Anansi some lemonade. We can start to think about recipes for lemonade. What would we do if Anansi had friends helping him? What would we do if we're making lemonade for all of our class? What's the ratio of lemons to water? How much lemonade would Anansi drink during the day if he drank 1 glass every hour? Those sorts of questions. I'm thinking of trying to do this with a group of kids at a school near me, and the end of the activity will be making a bean stew for the parents when they come and collect everybody, because that we'll need to think about recipes, and we'll need to think about servings, and we'll need to think about how much we'd have to spend and how much we might sell it for. So you can see that just from that, the Anansi story about the bean stew, thinking about it with a mathematical hat on, just suddenly all sorts of ideas were flashing into my head of different ways that we could use it mathematically. And I thought, well, is it just because I've chosen an Anansi story? So I wanted to look at the book that my grandson was reading, and he was reading a book called The Midnight Gardener, and that's a page out of The Midnight Gardener, which I just opened up at random. And again, I looked at that with my mathematical hat on and started thinking, oh, what questions might there be? I wonder how tall that tree is. I wonder how many children are in the orphanage, because there's at least 4 bedrooms I can see. So how many children I wonder if they sleep in bunk beds or single beds. I wonder how tall the windows are. I wonder how many bricks there are in that wall that we can see. So how many bricks will there be in the whole orphanage? So suddenly there's all sorts of mathematics that came out of that. And again, I worked on this with Felix, or we asked those questions. And I said, how tall's that tree then? And he said, well, it's the same size as the orphanage. So I said, well, is it bigger or smaller than our house? And he said, well, it's bigger. I said, how do you know it's bigger? Well, there's more floors in the orphanage. So he was starting to look at that picture in a slightly different way. That's right. And how big might the windows be, Charlene? And if by working from the size, and we can use the size of the children to think about the size of the windows. And one of the ways that we use the size of the people to think about how big the tree is. So suddenly we're starting to do all sorts of mathematics. Again, those of you that were here last time, remember that I used examples from the Explore Mathematics books in Jamaica that I've written in Jamaica, that I know Kingston Bookshop has, to show you how the real world could come into mathematics. And here are some examples of how these cross-curricular inquiries can build on the sorts of stories that I've been talking about. So the first one is thinking about the peas. If we've done that Anansi story about peas, we can start to think about, well, how many peas would fit on our classroom floor then? And of course, we don't literally put peas all over the floor. We might fill a 1-foot square outline with peas, and then we can multiply that up. Thinking about the chessboard problem, we can also think about how many squares are there on a chessboard. And somebody asked, and we can see there are 64 small squares. But if you look carefully, you might start to see that there are quite a lot of squares made up of 4 small squares. So squares that are 2 by 2. There are also squares that are 3 by 3. So they're made up of 9 small squares. So, and you'll notice that we're now starting to talk about the square numbers. So what we're doing is developing the idea of the chessboard problem and looking at it in a different way, coming from that same story. Somebody this afternoon talked about doing this on a geoboard, and I think that's a really good idea, because we can model the different squares on a geoboard. And finally, sometimes another form of story or creativity might be doing a role play, and this might be an example of how you could use role play for mathematics. So what you can do in your classroom is form small groups, and they all work for a packaging company that's packaging sugar cubes. And their task is to work out the best way to package sugar cubes. It's how many different ways can you pack 24 sugar cubes as a cuboid? And which do you think the best way will be to pack them so that you can fill boxes efficiently? So we're still if we're still telling stories, we're still being creative, but maybe that's a cross between creativity and the real world. Okay, so that's the end of what I've got to say. I'm going to take questions. Sorry, I paused because I just saw Nikisha's question, which I think is a really, really good question. And I've done some of this with 3 and 4 year olds online, and a lot of it is to do with asking them to find things or asking them to draw things and show me things. So if we're thinking about the dot patterns, that's something that they can do, and we can either show the children the dot patterns and ask them to show how many there are, or get them to draw things. Going and finding things is a really good way to involve children online, and actually finding YouTube videos of the stories and sharing those. If you're using Zoom or something, sharing that through the share screen, and you can share your images through share screen. And another thing you can do, and obviously it depends on the parents of the children, is set them a task to do that the parents can then take a photograph of, upload and send it to you later, which you can then use the next day. If students can't read, then we read stories to students who can't read, don't we? So it's just exactly the same. We read the stories, like I read the Anansi story to you, and the story is still engaging, I think. Somebody else asked me, I noticed a question coming through, which was about engaging boys in mathematics. And I think one of the ways of doing that is finding the stories. I've often found that boys really like the Anansi stories, actually. I think they like the cheekiness and the naughtiness of Anansi. But find the stories that the boys like and draw the mathematics out of those stories. Exactly, Kerry. Yeah. And that's just what I was saying, Joel. I think that you will know the stories that your children love, and you will know the stories that the parents of your children read to them, and you will know the folk tales that they know. And one of the things that I've started doing now as a result of researching for this webinar is I'm building up my own kind of catalogue of stories with the mathematics that I can draw out of them. So what I do is start with a good story. I don't start with the mathematics. I start with a good story and think of what's the maths that come out of that, and eventually I will have a catalogue of all the different mathematics in the story I can use. I think that one about Anansi and the pot of the bean stew is all about volume. When you start to think about the lemonade and how many glasses of lemonade Mikey drink, how deep is the pot? How much stew can he fit in the pot? How many beans would fit in the pot? So I think that one ties directly in with volume, Rona. Give it a go. Read your children that story and work on volume with them. Bring in a lemonade bottle. Bring in different pots of stew. Compare the volumes. There was a suggestion this afternoon about making lemonade and having different glasses that Anansi might choose to drink the lemonade out of, and showing that it's called conservation of volume. When you pour the same amount of lemonade in different shaped containers, it doesn't come up as far. Any more questions? Absolute pleasure, everybody. Like I say, I just wish I was with you all.
I think we'll leave it there, Tony. I think most of the questions have been answered. Thank you so much to Tony, as always, for a fantastic session. And I hope that the attendees enjoyed some of those stories. And I can see from the feedback that trying to implement this and trying to get students both genders involved would be really, really great. So thank you so much, Tony. Thank you to the attendees
Absolute
as
pleasure.
always. And just to let you know, Tony will be hopefully delivering sessions for us if he agrees to this in the upcoming months. So that would be really great. So we will let you know once we start planning our next set of webinars, and we will let you know in due course. So just before you go, a bit of information. The webinar recording and the PowerPoint presentation will be sent by email within 2 weeks. The CPD certificate will be automatically available as soon as the webinar finishes. And do follow us on social media and do email us if you have any questions. So thank you again. Take care, stay safe, and we look forward to seeing you soon. Bye.
Thanks, everybody. Thanks for being so active in the chat. Bye.